Welcome to newly joined Science Group Plus One students. One of the subjects you are going to learn is physics. I am going to take physics now. First of all, we can know what is physics. The word physics comes from the Greek word physis, which means nature. As per this word, the term physics, it is a branch of science which deals with nature and natural phenomena. You know, natural phenomena very well. Takes a cyclone. Take for example sunrise and sunset. So these are all natural happenings. So various seasons we are having, earthquakes, tsunami. So these are natural things. Here in physics, we are studying about all these natural happenings. So how they are arising, why they are arising. Suppose you take cyclone, at what distance it is formed in the ocean, in which direction it will be moving, at what time it will be crossing. So by this way we can study, we can measure all these things only in physics. Okay, so that it is called as physics, a science of nature. In physics we are involving, or physics involves measurement. So here this is otherwise called as the science of measurement. Physics is also called as science of measurement because it involves measurement. Without measurement there is no science. Okay, so physics is otherwise called as science of measurement. Okay, the next term we are going to see the scope of physics. What's the use of studying physics? So here this physics has many scopes. It is used in technology, industry, then various branches of science. We are using this physics. So you will be studying all these things in your textbook. It is given in detail, so you can study it later. So here I am giving only the outline to have depth of this scope, excitement and various applications of physics. You can go through a textbook, it is given in detail. So here next we are going to see what is physical quantity. Physical quantity. Here this physical quantity is a quantity which gives the physical nature of a body. Suppose you want to know about you, particularly take a boy. Suppose we want to know about his physical nature. So we are involving many quantities. For example, height of the boy, weight of the boy, then chest expansion, like that. So you can see various quantities to have clear idea about that particular student. Third quantities are called physical quantities. So physical quantity is a quantity which gives the physical nature of a body. So here we can take many quantities. Length is a physical quantity, time is a physical quantity, then height, weight, then force, then momentum. So you'll be studying all these things in your physics later. Okay, so next here to measure a physical quantity we are in need of a unit, that is called unit. What is meant by unit? This unit is an arbitrarily accepted standard. It is accepted standard of a measurement of a physical quantity which is accepted internationally. Am I correct? Are you able to understand? It is arbitrarily chosen standard. Arbitrarily, that is what arbitrarily chosen standard of a measurement of a physical quantity which is accepted internationally. Internationally means what? The entire world must be accepting that standard. That standard is called unit. For example, take meter. So meter is a unit. Meter. But this is what's the length of the meter? It is fixed by the international committee. It is a fixed value. It is a fixed value. We are accepting that value as meter. Okay. So meter is a unit. Similarly, mass. Take the mass is a physical quantity. Here the unit of mass is kilogram. So what is going to be kilogram? Is a fixed value given. In terms of the fixed value, we are measuring the various quantities of that kind. Suppose we want to measure the brinjals bought from the market. So by using this 1 kilogram stone, we can measure it. So by this way, by knowing that unit, we can measure the concern or that particular type of physical quantities. Okay, so this is called unit. So here, unit can be divided into two. One is called fundamental units. Another one is called derived units. So what will be fundamental units? Fundamental units are nothing but basic units. Basic units. They are not depending on other units. Okay, these are called basic units. Or in other ways also, you can use fundamental quantities also. Quantities. What are first we can see? What are fundamental quantities? So fundamental quantities are the physical quantities which are independent of other physical quantities. These are basic quantities. They are not depending on other physical quantities. Motha quantities are depend pannirukka. So they are basic. They are basic. So that's why they are called fundamental physical quantities. So fundamental physical quantities, example, length, time, mass, then temperature, then we can say current. So these are fundamental quantities. You will be studying your physics book all these in detail. Okay. So here the corresponding units are called fundamental units. Suppose you take a mass. Mass is the fundamental unit, a fundamental quantity. Okay, one of the fundamental quantities. Here its unit is kilogram, kg. Similarly, you take another fundamental quantity, length. Length. Its unit is meter. Symbol is m, smaller or inverse meter. Okay. So these are something about fundamental quantities and fundamental units. So fundamental quantities are the basic quantities which are independent of one another. The units corresponding to fundamental quantities are called fundamental units. The second one, derived quantity. What do you mean derived physical quantity? The quantities which are derived from fundamental physical quantities are called derived quantities. So best example is area. Take area. So what is area? Area of a room, for example. So length area of a rectangular room. So here length and breadth. So length is here. So actually length is a basic quantity, fundamental quantity, length. Breadth is also a length. So here length and length. So length and length gives you a new derived quantity, that is area. Okay. So now you take volume. Volume. What is volume of the cube? Side in the side in the side. You know the volume of cube. Side. One side is what? S, for example. Or A is one side. Length of one side is A. Another side A. Third. That means length A. Breadth A. Height A. So that's why it's a cube. So volume of cube is what? A cube. Okay, so here A, this is one side, this is also length, this is also length, this is also length. So here length is the basic quantity used. So that's why this quantity volume is called derived quantity of length. Okay, so here by this way we can derive various physical quantities based on the fundamental quantities. Then corresponding units we can see. Suppose take a unit of area. Unit of area is what? Unit of length is meter. Then breadth is also a length. So m into m gives you m square. Similarly here for volume, meter, here meter, here meter. So this gives you what? Meter cube. So this is the derived unit of volume. This is the derived unit of area. Okay. So here this is derived. So these are called derived units and derived physical quantities. So must be clear about what is meant by physical quantity. Two types of physical quantities. One is fundamental physical quantity, another one is derived physical quantity. Then next, based on this one, there are two types of units. One is fundamental units, another is derived units. Okay, so fundamental units are units which are independent of one another. Derived units are units which are derived from the fundamental units. Okay, so we can have clear about clear idea about this one. So next we are going to see how to derive the derived units from the fundamental units. For example, velocity. First you must know what is velocity. Velocity is what? Displacement divided by time. Displacement divided by time. What's the unit of displacement? Displacement is distance in a given direction. You will be studying later. So unit of this one is what? Meter. What's the unit of time? Second. Okay, yes. So this can be written as meter second inverse. So this is the unit of velocity. Okay. Similarly, suppose want to derive the unit of force. Force. What is force? Force is what? So what's the unit of force? We know what's the formula for force. We'll be studying later. This is mass into acceleration. So this is what's the unit of mass? M into E, mass into acceleration. Unit of mass is what? Kilogram. What's the unit of acceleration? So we'll be studying later. So this is meter second inverse, second power minus 2. Okay. So this is a derived unit of force. So another simple unit is there. That is what? Newton. So here you can see acceleration. What is acceleration? Acceleration is equal to velocity by time. Velocity by time. Velocity. You can write velocity by time. What's the unit of velocity? Already we have derived, So meter second inverse. What's the unit of time? Second. So you can write meter second to the power minus 2. So this is the derived unit of acceleration. So by this way you can derive various derived units for various physical quantities. It is given in your textbook in a tabulation. You can go through it. You can have better idea about this one. Okay. So next we are going to see units, system of units. System of units. See here, there are three types of units commonly used. One is called CGS system. CGS. Second one is FPS. Third is MKS. So first one, so actually you see that first letter refers to the unit for length, second for mass, third for time. So you see this is for length, this is for mass, this is for time. Okay, you can see in CGS system of units, the length is measured in centimeter. The mass is measured in gram, and time is measured in s per second. Okay, then FES system. F this is for length, you know. F refers to food. P for pound. Then s per second. See here M refers to meter. Here refers to kilogram. S refers to second. Okay, so these are commonly used three systems of units. So here internationally they have accepted that unit system, which is called MK system, otherwise called as SI system of units. So this is having some advantages. One is called this rational system of units. Why we are preferring this one? Rational system of unit. What do you mean rational system of unit? What's the meaning of rational system of unit? It has one physical quantity has one unit. That is the specialty of this MK system. This is a rational system of unit. Second one, this is coherent system of unit. Coherent. Co for C. So here we can derive the derived quantities or derived units from the corresponding fundamental units. For example, take then unit of area. You know, unit of length is meter. Unit of area is what? Meter square. So this is obtained by multiplication of meter 2 times. Here next one, volume you take. Volume is what? Side into side. For meter into meter. So meter cube. So here, that's why these are called coherent system of units. Similar, they are almost similar, you know, m square, m cube, like that. Like this you can write. This is called coherent system of units. Okay. Third specialty is what? Metric system. This is metric system of unit. This is a metric system. Here the powers will be obtained in the powers of 10 square, 10 cube, like that. So here this powers can be obtained, or this can be expressed in the powers of 10. That's why it is called metric system of units. So that's why these are the advantages of MK system or SI system. Nowadays we are using in all the branches of physics throughout this world. Okay.